So I'm going to do a video, a 3-part video to how to set up your electronic lab. It's going to be covering the basic test gear, test equipment, to components that you need to set up a decent lab, from small component to big components that I think personally are important to have in your electronic lab for your projects and things to do. Okay, first off, it's going to be your basic test gear, the multimeter. I started my electronic lab with this multimeter. Is a Unity 70D. It's a great little multimeter. It's got the basic stuff that you need. It's an auto ranging. I do not go near anything which is not auto ranging. I mean, all that manual ranging is just a piece of rubbish. Get yourself an auto ranging multimeter and you'll be fine. Anything over, if you spend over £80, £90 or £100, you're going to get a really good, decent multimeter. As you can see here, you got the AC and DC volt measurement, you got millivolt measurement, you got the capacitor, and you got diode, continuity, you got resistance, and you got amperage, you got the amp and milliamp. Unfortunately, this does not have microamp, which is nowadays important, because if you're doing work on like digital circuits and stuff like that, it's a good idea to know the power consumption of your project. So that's why I bought this from eBay. It's Fluke 87. Normal Fluke 87 is the original 87. Great little scope, great little multimeter this is. As you can see here, it does have microamp, very fast measurement. And I also bought this as well on eBay. This is the Fluke 89.5. As you can see, it's got a whole lot of different measurements and different stuff you can do with this multimeter. With this multimeter. And as you can see here, unfortunately, this is a great multimeter, but it's not as fast as this Fluke. This Fluke is really quick, taking measurements, especially in ohm, volts, and stuff like that. So at the moment, this is my favorite meter that I'm using all the time. So that's for the multimeter that you need. It's a good idea to have a couple of multimeters because you're going to be doing a measurement on amperage, volt at the same time, and things like that. And if you like you're doing a project and the multimeter is connected to measuring your amperage or voltage, it's a good idea to have another one if you testing other bits of your circuit, so you don't have to take this one out. You don't have to take this one out and trying to use it somewhere else. So this is connected to your one side of your project, another one's connected to another side of the project. It's a good idea to have at least 2 or 3. I personally got about 5 multimeters. These are the 3 that I use all the time. I've got 2 more other Unity. They're the Unity 61s that I bought as well. So it's a good idea to have at least 2 multimeters. The second thing that you need in your lab is an oscilloscope. I think oscilloscope is very important if you're doing analog work or digital work. I've got a digital scope here, as you can see, is a Wriggle 2102. This is 100 megahertz, but I've hacked this because these scopes are software crippled. I have hacked this, and this is now a 200 megahertz with all the options, all the math option and all the decoding options activated. Great little scope. I also got 2 digital analog scopes. I'm not 100% keen on that you must have an analog scope. It's it's not 100% necessary in your lab to have an analog scope, but if you can afford it, it's a good idea to get one. I've got these 2 from eBay, marked as faulty, but I managed to fix them both. This is 150 megahertz. This is a 400 megahertz. This Tektronix is the fastest scope that I have in my lab at 400 megahertz. These were advertised as faulty. I think the problem with the top one was the filter capacitors. They were blown. So I think the person who put this on eBay took a picture of it while it was working, and then there was smoke. Apparently smoke was coming at the back, so they put it as faulty. And once I got it, I took the hood up, and straight away I realized that the filter cap was blown. So I changed that, and it's been working ever since. This is the second scope. This is a really good scope, really sharp display. Great little display it's got. Again, there was issue with this. The problem with this was the controller board, the electrolytic capacitor, the electrolyte, I think was damaged. A couple of precision resistors, and I think the resistors were connected to a DAC, so it wasn't coming on. It was just giving up error. So I changed that. I changed the resistors and the capacitors, and it's been working ever since. These two are both 4-channel scopes. The wriggle that I have is a 2-channel scope, so I wanted to buy a 4-channel scope because it's great when you working on more than 2 signals. That's why I bought these two, and they've been working ever since greatly. Most important thing that you need is a soldering station. This is a 60-watt soldering station from Maplin. I've been using this for about 4 years. Perfect little soldering station. The only problem was that every now and then you got to change the tip, which is about £10. Not an issue. I bought about 5 or 6, so I have spares of this. I tend to use this for any heavy duty work, or if I'm taking apart circuit boards and stuff and salvaging parts, I tend to use this. And I've got a Vela soldering station here as well. If I'm using surface mount work and things like that, I tend to use this because it's got really fine head basically. So if I'm doing any intricate work or any surface mount, I tend to use this. Another important thing that you need in your lab is a power supply. It's a great idea to have a couple of power supplies. As you can see here, I've got one power supply here, another one here, another one here, and I've got another one over there. So I've got 4 power supplies, and sometimes I even need more. So I've got a couple of power supplies hidden under my desk as well. This is a dual rail power supply. As you can see, it's a switch mode power supply, 30 watt at 10 amp. Again, I bought this from eBay. There was an issue with it. I managed to fix it as well. All I had to do was change a couple of op amps, and it's been working ever since. As you can see here, it goes up to, you can see, up to 30, almost 33 volts. It's not, it loses regulation after 31 volts, so I'll just use it up to 30 volt, and it's perfectly fine. This is a dual rail power supply, so you can add them together in parallel or series to get different voltages or different amperages. This is the second power supply that I've got. Again, I bought this from eBay. It's a TTI power supply. It's supposed to be a triple output power supply, but there was an issue with this, as this didn't have a transformer. As this is a switching mode power supply. There was a problem with the switch mode power supply in it that was providing power to the front panel and everything. And what I had to do was I couldn't fix it, unfortunately, so I took it apart and I installed the big transformer into this I'll turn this into a linear power supply. And what I've done, I've got a big massive heatsink and a big fan inside, because this does go up to 30 volt at 4 amp. So if you're setting it to something like 5 volt or 6 volt or 2 volt or anything like that, the transistors are burning a lot of energy into them, lot of current and stuff into them. So you need a big heatsink and a big fan to cool it down. It's not a very efficient power supply as this one is, because it's a switch mode, but it's perfectly fine if I want to use a linear regulator with less noise and stuff like that. And this is an Agilent power supply. It's a precision power supply, 20 volt at 5 amp. I tend to use this if I'm doing any precision work, if I'm working on any precision stuff like op amps or voltage regulators or voltage reference or things like that. I tend to use this. This is a linear power supply, so it's very stable and very low noise. Perfect little power supply. Again, I bought this on eBay. It was perfectly fine, so I didn't have to do anything with it. And next thing you need is a function generator to create signals. I bought this function generator on eBay. Again, there was a problem with this, and I managed to fix it. The crystal oscillator on this was broken, so I managed to put my own crystal oscillator here. I've put an ovenized crystal oscillator. This does take about 2 or 3 minutes to warm up before you can use it. That only goes to 10 megahertz. There's another function generator I have. As this one was a DDS type, digital function generator, this is an analog function generator, so when you turn it on, there's no warm-up time or anything, you can use it straight away. That's why I still have this. 5 megahertz, quick stuff. If you want to quickly generate the signal, perfectly function gen. And this is my third function generator. The thing is, you do not need 2 or 3 of all of this equipment that you have. Like, I got 3 function generators, I've got like 2 oscilloscope, analog scope, 1 of that. All you need is just basically 1 of each. What I've showed you here to set up a decent lab. This is the function generator, goes up to 480 megahertz. I actually did a video on this. It's just something that I made myself with a couple of parts that I bought on eBay. I got a video of this on my channel, so if you're interested, you can go and take a look at it. 450 megahertz. This is a divider to divide the signal, and this is the frequency selector, and this is the fine tuning the frequency. It's got 3 output. 1 output goes to a counter, as this doesn't have a counter to show you what frequency you're at, and 2 output for whatever you used in a function gen 2. And you're going to need a counter for counting time bases, frequencies, and things like that. This counter goes up to 1.3 gigahertz. You don't need that much of a high frequency, but I bought it and it's a good idea to have. A great little counter. It's been calibrated, so a counter is a good thing to have if you're working on digital stuff, timing and stuff like that. I also got another counter over there which goes up to 70 megahertz. And if you're like me, you do work on digital circuits and stuff like that, it's a great idea to have a logic analyzer. You can buy a PC based logic analyzer, but I like everything to be standalone. I don't want to have a PC because I use my PC for different things. I don't want it to be working on something else as well. It's a Hewlett-Packard 1650 logic analyzer. Great little thing. I had to do a little mod because the power switch is all the way at the back, so I just brought the power switch all the way at the front. So these are the basic test equipments that you need in your lab for setting up a decent electronic lab. I would say the multimeter, the oscilloscope, power supply, soldering station, and the function gen are the most important things that you need. A counter, it's important, but not as important all the other stuff that I've mentioned to have. There are other stuff that you probably need. You might need like what I've got here, as this power supplies can do, if you connect them in parallel, you can do plus and minus, because these are dual rail. Once you set this to plus and minus 20 volt, you can only have obviously plus and minus 20 volt. What I've done is I've created this little breakout board. I put plus and minus 27 here, and what I get is plus and minus 5, plus and minus 12, plus and minus 15, and plus and minus 24. Sometimes you're working on circuits that you're going to need different voltages, so I've made this little, basically kind of a secondary power supply to get different voltages if I'm working on different projects, but all with the same ground. Basically, here, as you can see here, all of these voltages got the common ground to them, so it's a good idea to have something like this. Also, another thing that you might need, I believe is important now, it's a dummy load. As you can see here, I've built this myself. I've got the enclosure from eBay, and I built this. It goes up to 5 amp. What you gotta do is you gotta divide whatever it is on by 2. So if it's on 2, it's 1 amp, 2 amp, 3 amp, 4 amp, and 5 amp. I can adjust this and bring the scale down even further. So each will be divided by 5 instead of 2. So as you can see here, and I've got a multi-turn pot here to set the current. Great little thing to have if you're like me, you make power supplies for your project, or you make DC-DC converters and stuff like that. It's a great idea to have to characterize and test your power supply that you're building for your project, so you know exactly how much your power supply can handle and its limits, basically. Another thing I believe is a good idea to have in your lab is resistance box, decade box. If you're working on analog circuits and stuff like that, amplifiers or op amps and things like that, it's a great idea to have a resistance box. So you connect your whatever you want to set the resistor to this circuit, to these 2 poles, and then you can dial in whatever resistance you want. So obviously this goes to 10k, and then 10.10, one again, and another here. These are 0.005% precision resistance. So once you are happy with the resistance that you selected, you get your multimeter, put it through here if you want to quickly, or you can just read whatever number you set here. With the multimeter, you quickly put it here and you understand what resistance you want, and you quickly can select it through your resistance, and you can set it, make whatever resistance is here with your normal resistance for your circuit that you have in hand. So these are the basic stuff that you need to set up a decent lab, to be able to have confidence in your lab, to be able to test things and make things and basically fix things. So this was the first part. The second part, I'm going to be talking about the important parts and components that you will need to set up a decent lab, and to be able to make things and fix things and troubleshoot stuff, and for your project or for whatever that you're working on. Until next video, goodbye.